This is a donut. But donuts aren't just tasty pastries. You wouldn't want to eat this kind of donut because, well, it's 10 times hotter than the center of the sun. This is what the center of a fusion reactor looks like. A boiling mass of 150 million degree plasma being compressed by gigantic magnets. It's not just one star on Earth, it's 10. Fusion powers the sun. Atoms smash together, but a repulsive force like magnets pushing apart blocks them. Only the fastest or luckiest atoms break through. Boom. That's one fusion reaction. Now, scale it up to trillions of atoms. How could we ever figure out what happens inside these reactors? The answer? Simulations. Specifically, a simulation method called PIC. Imagine a grid. In each of the squares are donut holes. These donut holes are the particles, and the squares are the cells. Hence, particle in cell. Particles add parts of themselves to nearby grid points, depending on distance, in terms of the grid cell height and width. Then we multiply these distances in a special way for each corner. This way, we split the particles so that the crumbs always add back up together. We now know the energy and amount of hole at each grid point. Plasma particles are electrically charged, which makes them like tiny moving magnets. As they move, they change this magnetic landscape. Pretty complex, but there's a specific pattern PIC takes advantage of. Particles push the fields, and the fields push the particles back in a donut-powered dance where PIC is the choreographer. PIC mimics the precise movements of atoms without having to simulate trillions of them. Simulations like PIC are extremely important for telling us how an experimental, revolutionary reactor will behave, bringing us closer to a net-zero carbon future where we can turn this tasty treat into a literal star on Earth.